So this first session, just less than an hour, we'll spend on exam technique. Hopefully I won't run over too much, but there's a lot of content in this session. And then we're going to move on to energetics before we have lunch. So what we're going to cover in this session, we're going to look at interpreting questions. So there's going to be, but I think I've already said it, but I'll say it again. There's going to be a fair amount of overlap in this session between this session and the same session we had yesterday. So if you were here yesterday, there is going to be a lot of overlap, but we're also applying it to Year 13 or A2 questions. So it's not completely identical, but there is a lot of overlap. So apologies if you hear things you have heard before, but hopefully you'll keep paying attention because, you know, the more you hear the same things, the more they'll go in. So we're going to look at interpreting questions. So one of the things that students find particularly difficult is interpreting a question. Often students end up answering the question they think they've been asked or that they would like to have been asked, rather than the question they have actually been asked. And actually often students will read a question and then have a minor panic because they don't think they've learnt it or they can't recall something. So we'll have a look at interpreting questions. Should you know what you're being asked, or should you be able to work out what you're being asked? Is the content that you have been taught the exact stuff you're being quizzed on, or are you applying that content to a new situation? That sort of thing hopefully will help you feel a little bit more confident when you're answering exam questions. We're also going to talk about how to set out your answers as well. It feels like it's an obvious thing, but I can promise you that students still mess up because they'll end up giving an explanation when they only need a description, or they'll end up trying to recall content when actually they should be predicting content. They'll end up only perhaps giving one side of an argument when they've been asked to evaluate something. So there's common errors that we'll go through to help you to set out your answers to get maximum marks. We're going to look through some examples of command words. I really recommend you get confident with what these mean because it will help you when you come to answer a question to be secure on what they're asking of you. So we'll go through a few of them and explain what they mean, what they might ask you, etc. And we're going to talk through some tried and tested exam wisdom. So I've been an exam marker in the past, so I have got experience of marking and writing exam papers, so I can talk through what may or may not be expected from you. Okay, so our aim for today is to revise as much of A-level chemistry as possible. Of course, we'd love to be able to speed talk through a whole A-level in a day. I don't think my voice would cope, but we're going to try and do as much of it as possible, specifically some of the hard exam topics and ones that overlap with other topics. So we've done some of these, we've kind of done the basis of some of these yesterday, and we're going to be building on that today, but equally we've got some content here which is new to our seminar in terms of we didn't do it yesterday, but we have chosen content that can be used to summarize concepts and that can be used to apply to other concepts, and that where we can use our core knowledge to think about and understand it. We've also chosen topics that are covered by AQA, EdXL and OCR. Again, like I said yesterday, there is some, what's the word? Discrepancies, that's what I'm looking for. There is some discrepancies. So we've highlighted those when something isn't included in an exam board, for example, or where there will be significant differences so that you guys can double check what it is that you're expected to know. But yes, this is across the three main exam boards, AQA, EdXL and OCR. There will be content in here that is covered in other exam boards. If you are doing a different exam board from those main three, most of the content is the same. You'll just need to make sure that you're being specific to your exam board. So maybe you might need a little bit more or a little bit less detail, or the questions might be asked to you in a slightly different way. So just check that you're doing it for your exam board. So what do the examiners say? So this is every year exam boards, after the exam series, they release reports. The reports are written by the examiners, usually the high up examiners, and they tell you, or they tell the cohort what went well, what was a common issue that year. They give you insights into kind of themes across the exams. And so this comes out in a report, and it's useful for teachers to understand what maybe they taught well, what they didn't teach well, common errors moving forward, so that next year they can make sure they focus on those misconceptions, etc. So something that was said was questions that demanded an extended response proved tough, and only the best students were able to organise their thoughts into a logical sequence, enabling them to score marks. Score the highest marks, sorry. Key lessons from this paper are the need to develop mathematical skills and to place a far greater emphasis on doing and understanding practical work. This is a common theme, and I know, well, I'm sure that a lot of you guys will be thinking the same thing, that the practical questions are the hardest. Paper 3 is often the hardest for students. And I think it's because we don't get a huge amount of time for doing practical work in the normal classroom, teaching classroom, because there's so much content to understand. So the reports back up what your teacher and you are probably already thinking, is that I wish we could do more practical work and spend more time understanding it. Less able students did not use correct scientific terminology. For example, they interchanged the phrases or words atoms, molecules, ions, radicals, elements, and compounds without understanding what the correct word should be. And they were careless in the way they drew structures of organic molecules. Now, I do my best to be very specific, because within life, as well as within A-level chemistry, often we need to be specific because we mean a specific thing. So using specific keywords and understanding the exact meaning of those specific keywords is super, super important. Those key terms, atoms, molecules, ions, radicals, elements, and compounds, all mean something very specific. You can probably use the same word in different words in the same context, but they do mean something specifically different. So make sure that you're confident with what those words mean. And if at any point there is a keyword that you think, actually, I'm not sure if I know that that's the right word or not, do a quick Google, check in your revision guide or your textbook's glossary, because they'll have a specific answer, and compare it. Compare two keywords. Why have they used that word instead of that word? Why have they used molecule rather than compound there? Why have they used ion rather than atom there, etc.? What is the difference, and why have they been specific? Because most of the time they'll be specific. If you can, I would highly recommend you having a look through your past papers. Each exam board has information at the beginning of your specification, and I will talk about the specification multiple times, I'm sure, throughout the day. Each specification splits up their topics into different papers. There's different weightings for the papers, there's different marks available, etc. So just double check that you're happy which topics appear in which paper for your exam board. All the specifications changed in 2015, so there might be a limited number of past papers available. I think I said this yesterday as well. There was also a change in 2018 for some exam boards. There's been another change in 2022 as well. So, but I don't think, not major changes for AQA, OCR, Edexcel though, I will just clarify, but some papers have changed. So just double check that you're happy with exactly what's expected of you. What else was I going to say? Just, if you have your specification in front of you, that is what your exam board wrote. That is what they're going to be writing the exams from. And that is what hopefully your teacher has been teaching from. So your specification is your best resource for helping you with your revision. The newer papers that you'll take, so since the 2015 overhaul, have fewer multiple choice questions. They have more calculations, especially those which are unstructured. So by unstructured, it means they don't walk you through mark by mark. So you might find in some, if you go to look through past paper questions, that you have A, work out the moles of this, B, work out the moles of that, C, use that to determine the concentration of the starting solution or something. And that has given you a step-by-step of this is how you get to the end. Unstructured calculations is part A, determine the concentration of the starting solution. And there's no, first you need to do that, then you need to do that, then you need to do that. And students often find them really difficult. Often, questions like back titrations, for example, there's no step-by-step of this is how you need to get to the answer. And that can be very, very difficult. So there will be more of those. So just practice them, practice. Use the mark scheme if you need to take you through it. How did they work it out? Why have they used that number? Why have they just worked out that? What does that mean? How can I use that moving forwards? So use your mark schemes, past papers to help go through unstructured calculations if you find them difficult. And there are more questions based on practical techniques. So like I said before, this tends to be the stuff that students struggle with. I know that people find it hard. It is often one of the hardest bits. is doing the practical based questions, because it doesn't feel like it's a recall. It feels like it's brand new context and we shouldn't understand it. But I can promise you the exams have been very well considered. And if you come across a question that you think this is brand new stuff, I've never done it before, there will be something you can relate it to within the content that you have learned. It's just trying to work out what that is that's the hard bit. And then there are also more questions that require an extended written answer. So trying to test your scientific communication. The last 2 points are specifically because practical work is because they removed coursework. So if you haven't had the opportunity to do coursework, which used to involve a lot of practical work and explaining that practical technique and conveying in a scientific way, communicating in a scientific way, you haven't had to do that because you haven't got coursework to write. And so then the plan is to encourage you to expand your skills by putting those questions in the exam instead. It's all working towards, are you kind of making you a better communicator? Even if you're not aiming to go into scientific communication in the future, writing reports for any company, you need to be good at communicating. Writing summary emails, you need to be good at communicating. So this is all practicing. When you write your extended written answers, it's practicing communication. So it's all useful, hopefully. As we go through past paper questions, I will try, for the most part, I won't do it every time, but for the most part, I'm going to try and talk you through your approach to questions. Because like I said, often with students, the biggest, scariest thing is answering exam questions. So when you come to do your exam, that's the big scary thing. So I'm going to try and introduce a technique which helps you to approach exam questions. It's something that I do subconsciously, actually, when I'm looking at new exam questions that I've never seen before. It's something that I do subconsciously, but if you try and do it consciously, then hopefully it will become a subconscious thing once you've done hundreds of questions. So what we'll do is we'll start by looking at the context of the question. So the context of a question should help you identify the part of the specification that's relevant to the question. So you've in your head got all of these connections to all of this knowledge that you have made throughout your A-level journey. The first thing you can do is to flick to the filing cabinet in your brain that is on the right topic, because that has shortened or decreased the amount of knowledge you need to recall if you're only looking for a specific topic or a specific area within that topic. So the first bit, the context, should help you identify the part of the specification that is relevant to the question. So in this case, the question says, the table shows the standard electrode potentials for some half-cell reactions. There's a load of information. Then it says, explain, using information from the table, the color changes that take place when SO2 gas is bubbled slowly through an acidified solution containing VO2 plus ions. Equations are not required. So the first thing my brain has done has gone, right, the context is standard electrode redox potentials. That's the context there. So that's the area of the topic in my brain that I'm thinking about. I could even shorten it a little bit more to think about half cells as well. So redox potential half cell reactions. The next thing you can think about is, right, within that, what sort of thing am I expected to do? So what's the command words that are going to tell me the form my answer is going to take? Am I looking to explain some theory? Am I looking to draw a diagram? Am I looking to plot a graph? Am I looking to describe an observation? What is it that they're expecting from me? Because again, that's shortening within your topic what could be expected from you, or which parts of the information you're going to need to recall or you're going to need to use. So here we've got explain, using information from the table, the color changes that take place when SO2 gases bubble slowly, blah, 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 blah. So my keyword is explain. So they're looking for an explanation and it's worth 3 marks. So I need to think of an explanation that's going to be worth 3 marks. And then finally, oh, I drew a red line, don't know why. Finally, you can think about the direction. So this is the kind of the details that the question is giving you to help guide you towards an answer. So what are the directions? What are they looking for from me? So in this case, they're looking for the color change using information from the table. That's a key bit. They're looking for the color changes that take place when SO2 gas is bubbled slowly through an acidified solution containing VO2 plus ions. If you want to, you can go in with a highlighter, an underlining pen or whatever to highlight out these bits of information. That's absolutely fine. That's probably a good idea, especially to begin with. Actually, what I do now is I just take a quick note. So, right, I'm thinking standard electrode potentials. I need to explain. So what do I need to explain? Color changes from SO2 gas when it's being bubbled through acidified VO2 plus ions. Okay, and then I can go in and answer the question. Yeah, I'd really recommend you get into the habit of doing this yourself if you can. I'll also say, I don't know if I've already said it or not, I will go through lots of exam questions, but I won't necessarily go through all of them, but we will send out the answers to all of this at the end of the session. Once you've filled out your feedback form, we can then send you the answers. So if you don't manage to write down an answer, or you don't manage to get to doing a question, you can do it at a later date because you will have the answers to mark yourselves, okay? So don't panic. So if we're going to answer this question, this part was taken from an earlier bit of the question. So this is the beginning of the question. They've given us some information. Now, it's interesting to note they have given us the color changes here, but most of the time the color changes are expected. So the examiners, when writing this exam, have decided or determined that you shouldn't be expected to recall it at this point because maybe you've done enough recalling in the exam for now. So they've given you the colors, which is very nice, but they may expect you to recall it in a future exam. Just a quick note on exam technique. I don't think I mentioned this yesterday, so I'll say it clearly today. The way exam questions are set out is very specific. They have exam writers spend a long time making sure that they are set out in a clear and communicative way. Anything that is part of question 3, if you have got content like here, we've got content for question 3, and there's no part A or part I or anything like that, it's just question 3. That tells me that all of this information that they have given next to question 3 is relevant for the whole of question 3. If we go to the next bit, part B, there is extra information given for part B, that table there. That is telling me that only that table is only going to be useful for part B. I might need an answer that I get in B to use for part C, perhaps, but the information they have given me is applicable to part B. If it was applicable, or if I needed to use it for part C as well, they would need to have put it in the main bulk of the question at the beginning, not in part B. So it's just a useful bit of exam technique, question kind of analytics, working out how these exam questions are set out. I know that this information for part B is useful within part B. I can also see that there's a part I, so BI. So that's telling me there's likely to be a BII. And the information in the table is also applicable to BII, not applicable to C or to A, but it is applicable to the whole of part B. So it's just something to think about. Hopefully that makes sense. Let's whiz through this as a question because we don't have time to do all of them, unfortunately. So explain using information in the table the color changes that take place when SO2 gas is bubbled slowly. So I'm just going to highlight SO2 gas there. It's bubbled slowly through an acidified solution containing VO2 plus ions. So if we find those as well, that's there. So they want us to explain what is happening. We've got 3 marks to do it. So the standard electrode potential of redox system 5 is more negative than redox system 3 and 4. So that's the one containing SO2. It's more negative than 3 and 4. So SO2 will reduce VO2 plus to VO2 plus. So that's going to reduce. Sorry, that's going to oxidize. I used the wrong word. SO2 is going to oxidize, which is the reverse process of reduction. That's going to reduce VO2 plus to VO2 plus. And then it can reduce VO2 plus again to V3 plus. The color changes were actually given earlier in the question. But as a quick rule, we won't be able to do this for all of them. But with vanadium, we've got some color changes we need to remember: +5, +4, +3, and +2 for vanadium. And they are yellow, blue, green, violet. And the way that I've always remembered it is you better get vanadium. So you better get vanadium right. Now, so yellow, blue, green, violet, decreasing in charge order. I'm not going to be able to give you all of the tips and tricks that I have, but I would do my best. Just have a quick think. We're going to come to electropotentials later, but just have a quick think. Why will the reaction stop there? Why won't we get further reduction happening from of V3 plus to V2 plus? It's because the reduction potential of SO2 is not more negative. So it will actually go in the forwards direction. It will be reduced compared to vanadium 3 plus. So it can't force vanadium 3 plus to be reduced. We'll come back to that later if you're not happy with that. If you do have questions and stuff, please send a message to the messenger or drop us an email as well. Okay, let's keep going. Yes, let's keep going. Just double checking there wasn't anything else I wanted to say. Okay, so interpreting questions. You'll find that questions tend to come in 4 different types: statement questions, short answer questions, calculation questions, and long answer questions. We'll go through some different examples of each of these in a second. So, statement questions. I'm going to just take a drink in a sec. Statement questions. They are a test of rote learning, your ability to remember or recall facts. Some of these facts, you don't actually have to rote learn them. You can understand the theory behind it and then use that to work something out. And that I'm a big advocate for that. So you'll notice throughout, I'll try and mention it a couple of times if I can. If you can understand something, you can then apply your knowledge to a wide variety of situations. If you just rote learn something, as soon as you get a new situation, it's very difficult to then apply your rote learning to a new situation. So these are statement questions and similar, do tend to be recalling facts, but those facts don't have to be recalled directly. It could be that you're recalling the theory and then you're applying it to a new situation to answer the question. Questions usually require information that's given in the specification, and they may have some context from which you will need to interpret or extract the subject of the question. So some command words that you will see in an exam will be things like name, state, define, write, balance, construct, identify, determine. You might see multiple choice questions, or you might be asked to draw. And examples in an exam, they might say, name the mechanism of blah, 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 state the conditions for blah, 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 define the term identify the compound that blah, 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 or draw the product of blah, blah, blah. So that's how you might see these questions in an exam. In your specification, so I've said multiple times, use your specification. It is so useful. It is the best resource out there for you. I highly recommend, if you haven't already, get a copy in front of you now so that you can use it as we go through, but also spend a day, if you can, just getting to know your specification, understanding what it means, how it's conveying information, what is expected of you, the details that you may or may not have missed. You can literally use it as a checklist for your revision. Do I know that? Yes, tick. Can I understand that? Oh, no, might need to come back to that. I'll put a star by it. Do I know that? Oh, well, that doesn't make any sense. I don't think I've ever seen that before. I better go and talk to my teacher about what they're asking for there. So it's a really, really good idea to get comfortable with your specification. And within your specification, if you could be expected to answer a statement question on something in your specification, they will be saying things like, students need to know that, blah, 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 blah. Students need to define, blah, 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 blah. Students need to state that, blah, 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 blah. So in your specification, you'll see statements such as students need to define the key term, whatever. Students need to know that the color changes, blah, blah, blah. Okay, not all specifications are the same. Some are better than others. I will say that I do have preferences because some specifications are written more fully or more detailed. Some are left a little bit more open to interpretation, and I get that. But all three, AQA, OCR, and LXL, all three of those specifications have their pros, but also their cons. So whichever one you're on, whichever exam board you're doing, I promise you there will be some cons, but there are also some pros of that exam board. So some of them are better than others, but they're all better than others in different ways, which is why they're still all here and all still being used. Okay, so some examples of some statement words, some command words, sorry, statement command words are name or state. If you've been asked to name or state something, then obviously you just need to give a simple 1-word, maybe 2-word answer or a short sentence. Nothing big at all. You don't need any justification, any explanation required, but you do need to make sure you're using scientific terminology correctly. So if you've been asked to state the definition of electrophile, an electrophile is an electron pair acceptor. I have to make sure that I've used the word electron. I have to make sure I've called it a pair, electron pair, and I have to say acceptor. I can't say particle pair acceptor. I have to use the right keywords. Sounds obvious, but keep that in mind. Don't waste time writing more than is necessary. I know that that is a temptation for us. I do it. You can see when I talk, I often talk more than I need to. It's because I want to make sure that I've conveyed the information correctly. If you can, try not to waste time writing more than is necessary. If you've been asked to define something, then you need to be, where possible, word perfect. Now, there are some cases, as if you came yesterday, you'll have heard yesterday, there are some cases where, for example, with Hess's law or Le Chatelier's principle, they're a little bit more flexible. As long as you've conveyed the overall idea, you can get the marks. But there are some definitions which have to be word perfect. Again, you would have seen some of them yesterday. If you came yesterday, we'll see some again today, such as enthalpy change of combustion. There are some keywords which have to be in those definitions. So if they're not word perfect, if you haven't used what we're going to call the standard wording, you're unlikely to get the mark, because these key terms have very specific meanings and we have to convey that very specific meaning. I would highly recommend, if you haven't already, to use your mark schemes and your specification to find definitions. If you're finding it really hard to remember a definition for something, it's possibly because when you were learning it, you learned one definition. When you revised it, you learned a different one. When you did it in your exam, the exam mark scheme gave you a completely different one as well. If you're trying to remember 3 different definitions, it's so much harder than just remembering one. So I would highly recommend, if you haven't, get on your specification, look up in mark schemes and find the definition that they accept. That definition is the one that you need to learn, and forget all the others. If your revision guide says something different, ignore it. Find the one for your specification that they have used in past papers or that is written in their spec, and use that one. So for example, here, the question says, state what is meant by the term rate determining step. So I'm approaching this question, I'm thinking, what's the context? Well, rate determining step is the context. That is my, what's it called? That's the topic area. Sorry, my brain went funny then. That is the topic area. So I'm thinking energetics, kinetics, that sort of area. Command word is the next one. So state, so they're only looking for a small, short answer, one sentence. I have been given 2 dotted lines, and I will mention it again later on, I'm sure, but the number of dotted lines you've been given does give an indication for what kind of answer they're expecting. If it was a single dotted line, I'd be expecting to give a 1, 2, 3 word answer. Because I've been given 2 dotted lines, I'm expecting it to be a little bit more of a sentence. And then specifically, my direction is the term rate determining step. That's what they're looking for from me, is that term rate determining step. So if you were to answer this question, what would you put? I won't be able to give you too long to do any of the exam questions, I'm afraid. We just don't have time. If we want to cover content, we have to not have time to do questions. So what would you put? Hopefully something along the lines of, the rate determining step is the slowest step of a chemical reaction. And then you could also include, but you don't have to, which will determine the reaction rate or the overall reaction rate. They're looking for the slowest step of a chemical reaction. A little bit note from examiners' reports. The question just used the command word state, so no explanation is necessary. Some candidates lost the mark by including a contradictory explanation. And I think we come back to that later as well. It happens so often. Just got to be really careful. The more you waffle, the more you'll contradict yourself. And I probably do it. I probably did it yesterday. I'm probably going to do it a bit today. The more you talk, the more you contradict yourself. So just be careful. Identify/determine are other command words for these short statement questions. So these are key, and these ones I will highlight to you because this is telling me, if I see a question that says identify or determine, this is telling me there will be something in the question, be it data or information they've given in the question, or this specific context, which is telling me I have to apply it to that data, to that information, to that new context. This isn't a direct recall of theory that is in my specification. This is an application of knowledge question. So first off, I can take a deep breath and say, fine, I'm not recalling direct information from my memory. I'm applying my theory to a new situation or to new data or to new information. So look carefully at the context of the question and consider all possible options, eliminating incorrect answers. There will be information in the question that you need to use, be it the context, data, or just information, so make sure you use it. Something else you might be asked to do is to write/balance/construct. It usually refers to chemical expressions or reactions. They should always be balanced, but look for whether you need state symbols or not. I said yesterday, there are specific processes, reactions, chemical equations which rely on states of matter. There are more in A2 or year 13 than there are in AS, but there were still some in AS as well. And the state of matter is key for that process to be correct. We will hopefully look at a couple later on. If the state of the reactants and or products is important for the process, i.e. it's key for the process, you need to include those states. If it doesn't matter, if actually all we're interested in is the reaction itself and the state of the matter is not important, it's the reaction itself is important, then you wouldn't, if you haven't been asked for state symbols, you don't need to put them. Obviously, if you've been asked for state symbols, you need to put them in. If you haven't been asked, then double check if the state is important to the reaction or not. For example, I will give an example, enthalpy of formation. Elements must be in their standard states under standard conditions, and so states are important. If they're not in their standard states under standard conditions, it's not enthalpy of formation. And so in that case, state symbols are important. So even if they haven't asked for them, you should include them. Here we go. We've got a question to have a look at, which is an identify question. Oh, and then a write. Lovely. So the question says, compounds of calcium have many uses. Identify a compound of calcium that could be used to convert a soil pH from 5.8 to 7.5. It then says calcium phosphide, Ca3P2, is an ionic compound used in rat poison. Calcium phosphide can be prepared by reacting calcium metal with phosphorus P4. Write the equation for the reaction of calcium with phosphorus to form calcium phosphide. So first up, context. What's my context? Well, this is calcium, so I'm thinking reactions of metals of group 2 metals. The next question is command words. What's my command word? So first off, I need to identify a compound of calcium. Why have they said identify, not state here? It's a short answer because I've only got a single line. So why have they said identify, not state? The reason they've said identify is because this is not something that I should be able to recall. In specifications, the likelihood is that you have learnt that some compounds of calcium are useful in certain areas or in certain ways, but not perhaps for converting a soil pH from 5.8 to 7.5. So they've given us a new context, but there will be theory that you learnt in your specification that is applicable here. So think about what that might be. And then we have to write the equation for the reaction. So we're just writing a chemical equation. Directions specifically. Oh, my screen's just turned itself off. Hold on. Sorry, it did this yesterday. And then by the end of the, sorry, apologies. If that happens again, I'll just bear with me. I'll just have to tell it to reshare my screen. It did it a little bit yesterday. Hopefully it did stop doing it by the end of the day. So I don't know why it does it or why it doesn't do it. So apologies if it happens again. I'll just keep trying to bring it back up as soon as I can. And try not to lose my thought process. What was my thought process? Oh, directions. So specifically, we're thinking about a compound of calcium that could be used to convert the soil from 5.8 to 7.5. And our context in part 2 is the specific reactants and products that we need to put into our balanced equation. So what answer would you put? Hopefully you'd put some calcium carbonate for the beginning. Why? Why? Again, let's link it back to the specification. It's because the pH is going from 5.8 to 7.5. What's happening to that pH? It's getting more alkaline. So I need to add a salt that can react to produce an alkaline substance, such as calcium carbonate, a metal carbonate. Calcium carbonate is a base, can react with acids in the soil, which will make the soil more alkaline. Or, if it helps, less acidic. Maybe I should have used the phrase less acidic. So calcium carbonate is a base. It can react with stuff in the soil to make it less acidic and therefore more alkaline. The second question, hopefully our equation would have looked something like this. Should be balanced. We don't need to put our state symbols in. It hasn't asked for them, but also the state isn't important in what's happening. This is just a reaction between two things, so they wouldn't be expecting to see states. You can put them in, absolutely fine, but just if they're wrong, you might lose a mark for it. So just be careful. Okay, what about multiple choice questions then? Multiple choice questions. Often there's one, maybe two answers that you can see are completely wrong. Either they are just the theory is entirely wrong, or you can see that they're not applicable to the question that's been asked. There are then one or two other answers which are deliberately in there to confuse you. They're there to test misconceptions. This is why one of the reasons why we use multiple choice questions, because although you could randomly guess, they are useful for testing misconceptions. So just take your time, see if you can eliminate any answers that you're pretty sure are wrong. And then if you need to, perhaps you've only got two answers left. It's a 50-50 chance then, rather than 1 in 4. So if you can, eliminate any wrong answers that you know are wrong, the theory of them is wrong, and then if you need to, guess from the other ones. If you can work out the correct answer, brilliant. If a calculation is required, and often, even though multiple choice questions are single mark, often they will take more than a minute to do, which I know is frustrating. But equally, some of the answers will reflect common errors. So it's worth double checking. I know that it feels like you take forever on those questions, but it is worth double checking because some of the answers will be chosen to reflect common mistakes. So perhaps adding instead of timesing, or forgetting the final step, or not using the correct ratio, or whatever it is. So let's have a quick look at some examples. One way in which diamond differs from graphene and graphite is that only diamond has what, and then obviously we need to choose from those, or how many secondary amines have the molecular formula C4H11N, and we need to choose from those. Context for the first one, well, diamond, graphene, and graphite, my context is that I'm thinking structure and bonding of macromolecules, big molecules, and I can see the command word. There isn't really a command word, but I can see it's a multiple choice question. Directions. One way in which diamond differs from graphene and graphite is that only diamond has whatever. And then the second one, how many secondary amines have the molecular formula. So we're talking about amine chemistry. That's our context. Again, there isn't a command word as such. You can say how many or how is our command word, but specifically the molecular formula C4H11N. Again, I wish we had time to go through all of the answers, but we don't, so I am going to have to whiz through. The answer for part C would be C. So the top one is C, poor electrical conductivity. That's because technically, A, they both have a high melting temperature. B, none of them have a precise molecular formula. So A and B are definitely wrong because they all have a high melting temperature and none of them have a precise molecular formula. And D is wrong because they all, again, have a giant structure. Or actually, I guess you can say graphene doesn't have a giant structure, I suppose, depending on who you argue with. But the answer is definitely C because only diamond has poor electrical conductivity. So that's the answer. We make sure we're answering the question that's been given. For the second bit of the question, the answer is 3. Just remind yourself, if it's a secondary amine, how is a secondary amine connected up? It's a common error to think that a secondary amine, primary, secondary, tertiary amines are similar to naming primary, secondary, tertiary alcohols. It's not. With amines, you're looking at how connected the nitrogen itself is. So for a secondary amine, you're looking for 2 alkyl groups on the nitrogen. So the nitrogen itself needs to be connected to 2 carbons. And so there are 3 options for that with C4H11N. Do a quick doodle if you can and see if you can work out what those structures look like. Unfortunately, we don't have time. We're going to have to keep moving. So if you've been asked to draw, don't rush, but try to finish these questions quickly, as they can take a lot of time, more than their allocated time, and aren't worth a large amount of marks, a large number of marks. For example, this question says, you've been given a tripeptide. Draw a separate circle around each of the asymmetric carbon atoms in the tripeptide in figure 4. In this case, asymmetric here means chiral. So which of these are chiral carbons? Can only give you a couple of seconds to have a look. Hopefully we've recognized that this is amino acids. That's my context. The command word, is draw, and my directions are these specific amino acids, and I'm looking for the asymmetric carbon. So hopefully we have seen it's those 3. Those 3 are asymmetric or chiral. They haven't told us how many, so we just have to make sure we've got all of them, and it's only worth 1 mark. So again, we need to make sure we've got all of them to get the mark. Okay, let's keep going. What about short answer questions? So short answer questions require only short, approximately 2-line answers. They test your understanding of general principles or meaning of qualitative results, and they can be combined with calculate questions. The command words you might expect to see are explain, describe, suggest, predict, plot, sketch, or draw. And some examples would be explain why, describe how, suggest why, plot a graph of, draw the mechanism for, whatever. Again, in your specification, for some of these short answer questions or things you might be asked a short answer question on, you'd be looking for phrases such as students should understand that, blah, blah, blah. If they say, if you're expected to understand that something about something, you should be able to explain it. That's where the explain comes in. You might also see students should know that, which feels a little bit more like a state, but a description can also be used as a recall. So you need to know that the color changes, whatever, orange to green, or whatever. And you may also even have students should be expected to explain the process of blah, 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 blah. So those are the kind of things you can look for in your specification. So if they've asked for explain, you need to give step-by-step logical reasoning for why data or experiments show what they show. Look at the number of marks you've been given. If they've asked, if it's a 3-mark explain, you need to make sure you have explained it to level 3. You make sure that you have given 3 marks worth of explanation. Don't just state one thing and think you can get 3 marks for it. Make sure it has 3 levels to it or 3 parts to it to get 3 marks. Give a well-developed line of reasoning which is clear and logically structured, obviously. So, for example, explain why sodium oxide forms an alkaline solution when it reacts with water. Because this is an explain and not a suggest or justify or identify, I know that this will be somewhere in my specification in some form. What would we put? Can't spend too long on it, I'm afraid, but what happens? For example, sodium oxide contains O2- ions, which react with water to produce OH- ions. The number of dotted lines, oh, we said this before, the number of dotted lines given for the answer is indicative of the length of answer expected for the question. We were only given 2 lines here. We only need to give a short answer, or a short answer is all that they're expecting from us, let's say. You might be asked to suggest or predict. This is an application of knowledge. These are the questions I mentioned already. You can take a breath and just go, right, this is not content I'm expected to recall. So I need to figure out what content I do know that I can apply to this question. Okay. Personally, I find suggest or predict questions very difficult because my brain automatically goes, right, I need to be able to recall something then, don't I? What do I know? What do I know? And it can be quite difficult to filter out the information that is expected of you. So application of knowledge questions are hard, but you don't need to be able to directly recall things for it, but you do need to recall theory to apply to it. You must determine which topic is related to the information and then apply the relevant knowledge. Yeah, good. Often information or context that is not on the syllabus is provided. There should be at least something, even if you can't identify it immediately, there should be at least something that is telling you the new context or the new content. If any new information is necessary, they will give it to you. Exams are, I know it doesn't feel like it sometimes, but they are, a lot of time is spent writing exams and making sure that as much information as possible is given where needed and that the expectations are in line with your specification. So you should be given information if it's needed. Suggestion questions often include another command word, for example, suggest an explanation, suggest a name, suggest a description, etc. So here's an example. The entropy change of solution of K2SO4 is positive 225 joules per Kelvin per mole. Suggest, in terms of the states of the particles involved, why this entropy change is positive. So context, entropy. Specifically, my command word is suggest. So I have not been given this exact context, but I do have theory to be able to work out what's going on. And specifically, I'm looking at K2SO4, solution of K2, the entropy change of solution of K2SO4, and it's a positive value. So why would it be positive? So it's only worth 1 mark, but they've given us a lot of space for it. So that suggests to me that I might need maybe a slightly longer sentence to give my answer. An answer we could have given would be potassium sulfate is solid, it's ionic, so it's going to be solid at room temperature, meaning it is ordered and has a low entropy. Solids are ordered and have low entropies. When we dissolve them, so this is entropy change of solution, something going into solution, entropy increases as it dissolves as ions become less ordered in solution. Lovely. 1 mark. What about plot? And I'll say again, we will send over the answers. So if you haven't managed to write something down, unfortunately, we don't have time to spend too long waiting for on answer slides. So we will send over answers so that you can double check and write it down anything or correct anything that you need to. So what about plot, sketch, draw? Picking the right axes and scale are the toughest parts. They are hard. Practice these, as it's easy to think you know how to draw graphs and to skip them when revising because they're boring, aren't they? They take forever and they're hard work. Or maybe you like drawing graphs. Brilliant if you do. I personally don't. But it's a really good idea to practice them. Practice makes you faster and less likely to make mistakes. They are what I'm going to call easy marks. I know they're not actually easy, but they're easy marks in terms of it's the same thing every time when you're drawing a graph. You have to make sure you've got the right axes, the right scale, and that you're filling the graph paper to more than 2/3 of what you've been given. And then just make sure you're plotting as neatly as possible. For example, this question asks us to plot a graph of 1/time on the vertical axis against concentration of iodide ions. So context, these are 1/time versus concentration graphs. The command word is plot, so I need to make sure I'm being nice and specific, trying not to be too slow, etc. And my direction is I've been given those points to plot. Let's make sure, though, that I'm plotting the right ones. I've been told what to plot. 1/time on the vertical axis against concentration on the horizontal axis. So make sure that you're using the correct bits of data from the table. So 1 over time is over there, concentration is over there. So those are the ones I need to use. I don't want to use time in the middle. The middle column, I'm not interested in to plot this graph. I don't have time to plot it now. We're already running out of time, so I'm really sorry, but I'm not going to have a go. But hopefully you could have a go at plotting your graph, and then I assume you would use it in the next part of the question, but we've not shown that. Okay, need to keep going, so I'm definitely running out of time. So calculation questions are quantitative questions. They include deduction of equations sometimes. They might require you interpreting data sets, figures, equations, or graphs to obtain values required for calculations. They might have multiple dependent steps. Now, I've definitely said this yesterday, so I'll say it again today. If you can't do a step, make up a number. Say, assuming the number of moles of sodium chloride is this, and make up a reasonable number, 0.2, 1.5, 2 moles, whatever it is. Don't go for 1,000 moles because you'll just make your life really difficult and it will feel weird moving forwards with those numbers. Come up with what you consider to be a reasonable number and just say, assuming the moles of sodium chloride are this, and then use that number moving forwards. If you think you could do the end of a back titration question, but you can't work out a beginning bit of the calculation, skip it, make up a number and use it moving forwards, because you can get working out answers. As long as you're clear to your examiner what you have done. So I have made up this number. So you'd say something like, assuming the number of moles of this is this. Then your examiner goes, right, okay. So they didn't know what that was, so they don't get that mark or any of the previous marks, but I can give them that mark because they've used that number correctly. I can give them that mark because they've used that number correctly. They've applied it here so they can get that mark. You can get yourself a lot more marks than you think if you can't start a question. That's similar if you get halfway through and you can't get it, but you think there's more to be done at the end. Make up the middle number and keep going. 100% I would recommend. So command words you might be expecting to see: calculate, determine, or just show your working. So they might say determine something and show your working. That means they want to see your working because there will be marks available. It is heartbreaking as an examiner to have blank space and an answer and you can't see what they've done and the answer's wrong. And if it's a 3-mark question, they've lost all 3 marks because they've made an error that you can't tell where. And I can't give any marks for working out because they haven't given me any workings. So really, really would recommend showing your working as clearly as possible. It will help you for when you're checking your own answers because you don't have to, you can follow your own process. And B, it's helpful for your examiner for assigning marks. So for examples, calculate a value, determine the value of, show your working of, blah, blah, blah. In your spec, again, it'll be things like they'll ask you to calculate, blah, 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 or determine. You might be asked to determine something as well. So students should be expected to determine the concentration of blah, 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 or whatever. Let's keep going because we're running out of time. So calculates require a numerical answer to the correct number of significant figures and with units. Set out your work step by step. I've already said this. Include all of your steps, however small, and make it clear what you're working out. This is the number of moles of sodium chloride in 25 centimeters cubed. I know it's a lot to write, but that tells your examiner exactly what that is. And also, if you're then looking to work out, for example, from 25 to 250 centimeters cubed, you've reminded yourself you've only done 25 and you need to then convert it into 250 centimeters cubed or something. It's really useful for kind of guiding you forwards as well. You usually get a mark for each piece of working and state any relevant formulae, even if you can't start the calculation, because if it's a formulae that needs to be recalled, often there's a mark for it. For example, in KC questions or KP questions, just stating the KP formula, if it hasn't been given to you, will get you the mark because you've written a correct formula, for example. We're not going to have time to go through this in any detail, but please feel free to have a go at it yourself. So we've got an equation. They've asked you to calculate the carbon-oxygen mean bond enthalpy using mean bond enthalpies given in the table and the enthalpy change of reaction. So there's 2 things you've got to calculate there. And I would highly recommend when you come across a question like this, where the second thing is kind of sneakily hidden in the question, highlight it or put a star by it. Remind yourself that you're calculating 2 things, the mean bond enthalpy and the enthalpy change of reaction. Because the number of times students get halfway through a question and think they've finished and they've lost, you know, 2 marks because they've only done one thing instead of 2. It happens a lot. Again, I won't be able to go through it now, but have a calculate, blah, blah, blah. With these questions, do think about whether or not, with any enthalpy question, think about whether or not the value you're giving should be positive or negative. Are you expecting it to be positive? Or are you expecting it to be negative? Because the number of times, again, students miss signs off, and then you lose a whole mark for that. It happens far too often. Okay, a couple of top tips for maths. These are the same as the ones yesterday, but I'm going to go through them again. Make sure you can rearrange the subject of an equation. Try the triangle method if you find normal rearranging hard, but unfortunately some of the equations in A-level chemistry, such as PV equals nRT, it's harder to do a triangle method for that because there's lots of stuff going on. So if you can do normal rearranging, I would really, really recommend it. But triangles, remembering equation triangles are useful anyway. It's good just to check that you can rearrange and solve a quadratic equation using the factorization or the formula, because it is expected of you. I know that it's not often used, and I know that there are very few past paper questions that use it, but it is expected of you. You need to understand ratios. Ratios are a huge part of A-level chemistry, on the math side, so definitely get confident with those. And don't forget to look out for your units and practice conversions. We nearly always have to convert volume, so make sure you've practiced that. Does your answer make sense? Is it the correct number of significant figures? Have you got the signs right, particularly in enthalpy calculations? Because the number of times they go wrong and students lose marks is frustrating as an examiner. For correct number of significant figures, you shouldn't give an answer that's to any more significant figures than the smallest number of significant figures given in the question that you have used to work out that answer, I should say. So if you've been given some numbers and you haven't used those numbers, then we don't care about those. We're looking at the numbers you've used to come up with a calculation answer. What's the smallest number of significant figures given? That's the number of significant figures you need to give your answer to. 20% of the overall assessment will contain mathematical skills at GCSE level 4 or above. So it is expected, unfortunately. And it's at least 20% of the overall assessment as well. So set up little red flags for yourself to look out for all of this stuff. Look out for units, make sure you get your units correct. At the end of every question, check, does your answer make sense? At the end of every mathematical question, check the correct number of significant figures and check, should I have put a sign in or not? Okay, what about longer answer questions? We are going to run over ever so slightly into our energetics time, but that should be okay, I hope. So longer answer questions. Long form answers are ones that are going to need approximately 5 or more lines. They are ones which are asking you to interpret or analyze, including comparing data, figures, and methods to explain how to conduct experiments with diagrams, if diagrams are necessary. They test practical knowledge in unseen contexts, which is why we find them so difficult, and they might require mechanisms. So OCR specifically likes to put in a mechanism. Longer questions are marked using levels. This is because they're trying to test your quality of communication, scientific communication. Again, I said this at the beginning. This is not because you need to be able to convey this specific scientific information, but because within life, within your working adult life, you need to be a good communicator. So it's a skill we have to practice. So you need to make sure your answer is coherent, logically structured, and with correct use of terminology. You might be expected to do a long answer question that asks you to describe, explain or justify, discuss or evaluate, or deduce, or possibly a multiple of 2. Examples are describe how, or explain or justify why, discuss or evaluate the effects of, deduce why, blah, 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 blah. There's quite a few things that you might find in specifications that indicate that these are these are possibilities for longer answer questions, such as students are expected to use blah, 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 to do something. That's telling you it's probably going to be a longer answer question, an application of knowledge question as well. Explain, that might feel like an obvious one, but it will be in there. You might be asked to understand, or students should be expected to understand something. Again, this could be asked then in a longer answer question. There's sometimes they even say students will be expected to evaluate and that doesn't even evaluate. Sorry, can't spell. There we go. And even in some exam boards, they say students will be expected to discuss something. This is telling you very explicitly that you could be asked a longer answer question on that content. So if it says describe, just describe what is happening, what you can see. Often students, if you're asked for an observation or asked to describe what you see, they start talking about the theory behind it. That's not answering the question. They want an observation. They want to know what you can see. So make sure you're including those. If they've asked what you can see in a graph, make sure you're describing the trend in the graph and not, again, explaining the theory behind the graph, etc. So show how a process will progress in a series of stages. You might be asked to do that. For example, describe what you would observe when dilute aqueous ammonia is added dropwise to excess to an aqueous solution containing copper-2 ions. Write equations for the reactions that occur. Again, the number of dotted lines in the answer is indicative of the length. So this is 4 marks and they've given us a few lines for it. So they're expecting a decent amount of information from us. Again, I can't give you any time for this because we are running over. But please do feel free to have a go at these questions at home. But this content does vary ever so slightly between exam boards. We'll mention it again in the future, later on. But something along the lines of a blue precipitate will form when dilute aqueous ammonia is added dropwise, and then it will dissolve to give a dark blue solution as it's added in excess. And these are the equations that support that information. Again, we will look at this later on. What about if you've been asked to explain or justify? So you will need to give a step-by-step logical reasoning for why data or experiments show what they show. So this is explaining the theory or justifying the result of a practical or something. So give a well-developed line of reasoning which is clear and logically structured. They might ask you to write out the steps for a method, for example, and even maybe justify some of those steps in the method. And there might even be some calculations. Again, here's an example. Use the concept of electronegativity to justify why the acid strengths of ethane dioic acid and ethanoic acid are different. I'm not going to go through this because it is a 6-mark question and we'll be there for ages. We will email out the answers so you can have a go at this in your own time and have a read through the answers that we've given. But because we are running late and we do want to try and cram in as much content as possible for you guys, we'll keep moving. So how do you set out a longer written answer? These often scare students, and I do say I'm not sure most teachers could get 6 out of 6 on some of the longer answers, or even 9 out of 9 if it's a really long question or whatever, or, you know, get perfect marks in a biology essay or whatever. We can't. What you should be aiming for is 80 to 90% of the marks. But to get you there, to help get you there, think about writing it clearly. Think, then write. So don't just go straight in and start writing. Take a second to take stock of what do I know? What points am I wanting to get across? How's best to set them out? Then refer back to the question. Again, before you start writing, once you've got it in your head, maybe you've made a couple of notes, then refer back to the question. Am I answering the question that's been asked or the one that I think's been asked? Or the one that I know a lot about and so my brain has tricked me into thinking that's the question that's been asked. So just double check, make sure you're answering the right question. Make sure you use scientific terminology and use it correctly. Spelling is not the end of the world unless it's important to the word. So intramolecular versus intermolecular does matter. But if you spell thermometer with the RE round the wrong way, it's not the end of the world. Keep it simple, clear and concise if you can, and just try and get as much across as clearly as possible. Material that is not required by the question is not penalized. So if you write extra stuff that you're not going to get a mark for, that's fine. But if it contradicts what you've already written, then you will lose a mark. So just be careful. And obviously you don't want to waste time, but equally you do want to make sure you've written enough to get all the marks. Also remember, you're not writing an essay. You don't need full sentences. You don't have to start with the a rewording of the question every sentence. You can just make bullet points if you need, as long as they're clear and scientifically correct. As long as there is a structure to it, that's fine. You can include subheadings like we did in our previous question to help your examiner see where you're hoping to get the marks. A well-labeled diagram will also get you marks. If it's well-labeled, not just a diagram, a well-labeled diagram will get you marks because it's showing your understanding of the theory. And if you're short on time, just jot down equations or key facts in the hope you can get marks for those. Leave a question and come back to it if you're drawing a blank. Another question might give you some ideas. Candidates should be cautious about writing long answers, as this can increase the possibility of them contradicting themselves and can reduce the clarity and coherence of their answers. We know that anyway. Okay, finally then, some top tips. Distinguish between what you need to learn, what you need to understand, and what techniques you need to master. So what skills you need, what you have to recall from memory, and the things that you might be expected to explain or apply to new situations. Again, use your specification. This is where those students who know their specification well will spend less time, will waste, less of their revision time, because they will be learning the right things, understanding the right things, and practicing the right skills. It's not easy. I know it's not easy. It's why A-level chemistry is one of the hardest A-levels, in my opinion. But your specification can be really helpful. Know what you need to know. Again, look at the specification. Your specification tells you what you do and don't need to know. For example, all three of these the main exam boards tell you do not need to learn the equation for Arrhenius. You may choose to learn the logarithmic version of it because it's not given, but you don't need to learn the Arrhenius equation, K equals AE to the minus EA over RT, because it's not given. These equations, for AQA, these equations and the gas constant R will be given when required. For EdXL, the Arrhenius equation will be given if needed. For OCR, equations are provided on the data sheet. Okay, so don't learn what you don't need to learn. If you don't have to learn it, don't learn it. I said this yesterday, I'm going to say it again. I know we are running over, so I will move on to energetics very shortly. But if you haven't gotten comfortable with your periodic table, if you don't use your periodic table regularly, I would highly recommend you use it in your revision. I would create, if you can, print out a periodic table nice and big in the middle of a massive piece of paper and just apply your revision around it. Because the periodic table is given to you in an exam, so it can be a visual reminder for you about everything you've been revising. If you can apply, and you can, I promise you can, if you can apply a lot of what you're learning in A-level chemistry to the periodic table, so adding in notes about cobalt, adding in notes about group 7, adding notes about bonding and structure between group 1 and group 7, or metals and non-metals, adding in information about the transition metals, about oxidation states, information about trends in electronegativity, in reactivity, in atomic size. All of this can be applied to the periodic table. If you can relate it to the periodic table, then in your exam you are given a periodic table that is the basis of your revision resource provided for you. So I really would recommend getting to know what the periodic table can tell you and how it can help you in an exam. Master some common formulae. I'm assuming that most of you guys are in year 13, and so hopefully you know these already. If you don't, go home tonight and learn them, or tomorrow. Spend 4 hours if you have to over the next week learning them. If you don't know them off by heart, you will really struggle in lots of questions. I know it's easier said than done, but I really, really would recommend learning them. Learn your standard reactions as well. Again, it feels silly to say it, but we go through some of these in like Key Stage 3, and we don't necessarily revisit them explicitly, but it is taught early in the specification, early in the curriculum, sorry, as a basis for later knowledge. So make sure you know these, because this is assumed knowledge. And some chemical tests. Again, we went through these yesterday, but I'll go through them briefly today. You need to know the chemical tests. Most of them are written in your specifications, but GCSE knowledge is assumed, and some of these are in the GCSE syllabus. So just make sure you're comfortable with what they are, what they're telling you, how you know what the positive result should look like, etc. So just have a quick look through. What do you think any of these are? So we've got our melting point analysis there. Flame tests just below it. What's our lovely pop is a test for hydrogen. Above it, we're relighting a glowing splint. That's a test for oxygen. We've got bromine water decolorizing or going from orange to colorless. That is a test for alkenes. What about lime water turning cloudy? That's carbon dioxide, a test for carbon dioxide. And then that looks like a pH probe. So that's testing pH. This is not exhaustive. There are other ones. This is just a selection, but make sure you know them.